Now that we have these new definitions, let's try to apply them to some examples. Now my picture here looks kind of messed up with all of these crazy intersecting, but it's important to remember those transversal and intersecting lines. So I'm going to be color coding everything as we go through. Angles 1 and 5. So here is 1, here is 5. So how are they formed? Well, here's my intersecting line, here's an intersecting line, and it appears that the blue line M is acting like my transversal. So in relation to that, what kind of angles are 1 and 5? 1 and 5, so my transversal is line M. What kind of angles are they? Well, they both are above and to the left, so that means they are corresponding. They are in the same position. Erase all that and see what our next angle pair. What kind of angles are 3 and 12? Well, 3 and 12 appear to be formed by this line, and now my red line is acting like my transversal. So what kind of angles do I have? Where is everything relative? Well, 3 and 12 are outside of the intersecting lines and on opposite sides of the transversal. So that means they are alternate exterior angles, and my transversal is the red line P. Don't be afraid to draw in your homework or draw in your notes. It really helps things become more clear. What kind of angles are 10 and 4? Here's 4, here's 10. 10 and 4 are formed by line T and line M. This time, the red line P is our transversal. Now, 10 and 4, they're on the same side of the transversal. They're inside the intersecting lines, so that makes them same side interior angles. If I want to name another pair of same side interior angles, let's mix things up and use this line and this line as our intersecting lines. And let's use T as our transversal as an example. So if we're on the same side and inside, so we're inside these intersecting lines, we're on the same side, then that means that angle 10 and angle 5 are same side interior. If I switch it up and use a different set of lines, like this line and this line being my intersecting, then that leaves the blue line M here as my transversal. 4 and 5 would be my same side interior. So it's always important to know what your transversal and your intersecting lines are. This would be a great place to pause the video and try these 3 examples on your own, and then come back and check your work. One pair of alternate exterior angles. So I can determine right now, I'm just going to grab these 2 as my intersecting line, makes T my transversal. So alternate exterior, I need to be on opposite sides of the yellow T and outside the dotted lines. So how about 10 and 7, or 6 and 12? Angle 11 and angle 7, angle 12, and angle 6. If you switch it up and use different lines, your alternate exterior are going to change. Alternate interior. Let's go ahead and use T and M as my intersecting, which leaves me the red P as my transversal. So where are we on opposite and inside? Opposite and inside. Opposite and inside. So we're looking at angle 10 and angle 1, or angle 11 and angle 4. There are other examples using different lines, but those work well for that example. Corresponding. So let's pick this as a transversal, or as a line, and this is an intersecting. Let's use M as our transversal this time. Corresponding, they need to be in the same position. So they both need to be above the intersecting lines to the right of the transversal, or they both need to be below and to the left. So for example, angle 2 and angle 6, or angle 4 and angle 8. Remember, there are 4 pairs of corresponding angles for every set of lines. When it comes to examples like 8 and 9, we have to look straight at our picture. If we know angle 7 is 30, we're going to go ahead and write it right on there. What other angle measures do you know? Well, I'm really going to focus just on this area because that's all I know right now. My V angles, that means those are vertical, so I know angle 5 is 30. I know that these two form a linear pair, so this is 180 minus 30, so it equals 150. In the same way that I know that this is a linear pair, or vertical, excuse me, so I have 180 minus 30 is equal to 150 down here. So once I've worked on my picture, then I can go ahead and transfer my answers. So that means that angle 5 is 30, and angle 8 is the same as angle 6, which is 150. If I go ahead and look at the next example, if angle 3 is 2x minus 4, what else do you know? Again, I'm only looking at this top. I have my vertical angles right there, so that means angle 1 is 2x minus 4. These are single numbers. Now, in the previous example, we subtracted from 180 to find that linear pair, and so nothing has changed. So we can say 180 minus 2x minus 4 is angle 2. And if that's what angle 2 is, that's what angle 4 is 180 minus 2x minus 4. And the parentheses are very important because you need to distribute that negative. So if we were actually going to clean it up, we'd have 180 minus 2x plus 4. So you have to distribute that negative. And so angle 2 is the same as angle 4, and they equal 184 minus 2x. So that's just a little application of your algebra to your geometry. In the next video, we're going to talk about what happens when the lines are parallel, which is when things get very interesting.